Hello, in this lecture we will find the area of the green circle. In the drawing we have triangle ABC. Side AB of triangle ABC equals to 13 units, side AC equals to 14 units, and side BC equals to 15 units. And we have the green circle that it is inscribed in triangle ABC, and we want to find out the area of the green circle. We know that side AB of triangle ABC is tangent to the circle at this point. We will define this point as point D. Point D is the launch point between tangent AB and the green circle, or it is the point of tangency between tangent AB and the green circle. And we also know that the side AC of triangle ABC is tangent to the circle at this point. We will define this point as point E. Point E is the launch point between tangent AC and the green circle, and side BC of triangle ABC is tangent to the circle at this point. We will define this point as point F. Point F is the launch point between tangent BC and the green circle. And we will define side AB of triangle ABC as A. That is to say, AB equals to A, and we know that A equals to 13 units, and we will also define side AC of triangle ABC as C. That is to say, AC equals to C, and we know that C equals to 14 units, and we will also define side BC of triangle ABC as B. That is to say, BC equals to B, and B equals to 15 units. Okay? So in the next step, we will define a new term that is actually semi-perimeter of a triangle. So what is the semi-perimeter of a triangle? Actually, if you have triangle ABC, and the side AB of triangle ABC equals to A units, side BC of triangle ABC equals to B units, and side AC equals to C units, then the semi-perimeter of this triangle ABC, will be equal to the perimeter of triangle ABC, that is actually equals to the sum of its sides, that is to say A plus B plus C, over 2. Again, the semi-perimeter of any triangle equals to the sum of its sides, that in this case it is actually A plus B plus C over 2. And the semi-perimeter is marked with the letter S. So the semi-perimeter of this triangle ABC actually equals to S. S is the abbreviation for semi-perimeter, that equals to A plus B plus C over 2. Again, S, the semi-perimeter of this triangle ABC, equals to A plus B plus C over 2. Okay, so we actually can calculate the semi-perimeter of our triangle ABC, according to the formula for the semi-perimeter. So the semi-perimeter of triangle ABC, that is to say S, will be equal to A plus B plus C over 2. Again, the semi-perimeter of our triangle ABC will be equal to A plus B plus C over 2. Okay, so, but we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. So the semi-perimeter of our triangle ABC, this triangle, will be equal to 13 plus 15 plus 14 over 2. And 13 plus 15 equals to 28, and 28 plus 14 is 42, and 42 over 2 is 21. So actually the semi-perimeter of our triangle this triangle ABC, equals to 21 units. Again, the semi-perimeter of our triangle ABC equals to 21 units. So, in the next step, I will present to you a new formula and it is actually a new formula to calculate the area of any triangle, and we calculate the area of our triangle ABC according to the new formula. So the new formula for calculating the area of any triangle, A is the abbreviation for area. So the area of any triangle can be calculated according to the following formula. The area of any triangle equals to the root of S times S minus A times S minus B times S minus C, when S is actually the semi-perimeter of the triangle, and A, B, and C are the sizes of the triangle's sides. So the area of any triangle can be calculated according to this formula, and we will calculate the area of our triangle ABC according to this formula. We have already found out that the semi-perimeter of our triangle ABC equals to 21 units, and we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. So actually we have all the variables of this formula, and the only thing that is left is to put the data inside this formula and to find out the area of our triangle ABC. So the area of our triangle ABC will be equal to the root of S is 21 times S minus A is 21 minus 13, S minus B is 21 minus 15, and S minus C is 21 minus 14. So the area of our triangle ABC equals to the root of this expression. 21 minus 13 is 8, 21 minus 15 is 6, and 21 minus 14 is 7, so I'll write it down. We'll find out that the area of triangle ABC will be equal to the root of 21 times 8 times 6 times 7. So the area of our triangle ABC equals to the root of this multiplication. Actually, the outcome of this multiplication is 7056. So the area of triangle ABC equals to the root of 7056. Okay, the area of our triangle ABC equals to the root of 7056, and the root of 7056 equals to 84. So the area of triangle ABC equals to 84 square units. Again, the area of our triangle ABC equals, according to the new formula, equals to 84 square units. Okay, so the next step, we will find out the radius of the green circle. So first of all, we will define the center of the green circle as point O. Again, point O is the center of the green circle, and then we will connect together points A and O by a straight line. And we will also connect together points B and O by a straight line. And we will connect together points O and C by a straight line. Actually, here we created three small triangles, triangle AOB, triangle AOC, and triangle BOC, and the sum of the areas of those three small triangles equals to the area of the big triangle, triangle ABC, that actually contains exactly those three small triangles. Okay, so in the next step, we will draw three radiuses of the green circle that start from the center of the circle and end at the launch points, that are points D, E, and F. So the first radius starts from point O, and actually it is drawn to the launch point, that is point D. It actually touches the launch point, point D. And the second radius also starts from the center of the circle, that is to say from point O, and touches the launch point, that is point E. And the first radius also will start from the center of the circle, and the third radius is drawn to the launch point, that is point F. So we drew three radiuses that starts from the center of the circle and are drawn to the launch points, points D, E, and F. Okay, and we have a rule that is called rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to the launch point. So I will read rule number 1 again. Rule number 1 states that a tangent to the circle is perpendicular to the radius drawn to the launch point. So actually, according to rule number 1, whenever you draw a radius that is drawn to the launch point, that radius will be perpendicular to its tangent. That is to say, for example, this radius is drawn to the launch point, point D, and therefore this radius is perpendicular to its tangent AB. That is to say, this is a right angle, and this angle is also a right angle, because of the fact that that radius is drawn to the launch point D, and it is actually touches the launch point D. And the same thing is true about this radius. This radius is also drawn to the launch point, that is point E. Actually it touches the launch point, point E. Therefore, this radius is perpendicular to its tangent AC. That is to say, this angle is a right angle, and this angle is also a right angle. And the same thing is true about this radius. This radius is actually drawn to the launch point, that is point F. Point F is the point of tangency between tangent BC and the green circle. Therefore, because of the fact that this radius is drawn to the launch point, this radius is perpendicular to its tangent BC, that is to say, this is a right angle, and also this angle equals to 90 degrees. Okay? And in the next step, we will create an equality that states that the sum of the areas of the three small triangles, that is to say, the area of triangle AOB plus the area of triangle AOC plus the area of triangle BOC, equals to the area of the big triangle, triangle ABC, that contains those three triangles. Okay, so the formula states that the area of triangle ABC that we have already found out that it is equal to 84 square units, is equal to the sum of the areas of triangle AOB plus the area of triangle AOC plus the area of triangle BOC. I will mention again that A is the abbreviation for area. I will repeat again on this equality. This equality states that the area of the big triangle ABC, that we've already found out that is equal to 84 square units, equals to the sum of the areas of the three small areas of the area of triangle AOB plus the area of triangle AOC plus the area of triangle BOC. Again, the area of the big triangle ABC equals to the sum of the areas of triangle AOB plus the area of triangle AOC plus the area of triangle BOC. Okay? So, but what is the area of triangle AOB? The area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of triangle AOB will be equal to the base of the triangle, that is AB, times the height to the base. You should remember that the height to the base must create 90 degrees with the base, and as you can see from the drawing, the radius creates 90 degrees with the base AB. Therefore, the radius of the green circle is the height of triangle AOB. So it is actually the base AB times the height to the base, that is the radius of the green circle, over 2. So the area of triangle AOB equals to the base of the triangle, that is AB, times the height to the base, that is the radius of the green circle, over 2. And we also can find out the area of triangle AOC in the same way. So the area of this triangle AOC, will be equal to the base of the triangle that is AC times the height to the base. The height must create 90 degrees with the base AC. Therefore, the height of triangle AOC is the radius of the green circle, because the radius creates 90 degrees with the base AC. This angle is a right angle, and this angle is also a right angle. So, the area of triangle AOC equals to the base of the triangle that is AC times the height to the base that is the radius over 2. So the area of triangle AOC equals to the base AC times the height to the base that is the radius over 2. Okay? And the area of triangle BOC equals to the base of the triangle that is actually BC times the height to the base. Again, the height must create 90 degrees with the base BC. As you can see from the drawing, the radius creates 90 degrees with the base BC. Therefore, the radius is the height of triangle BOC over 2. So, the area of triangle BOC equals to the base of the triangle that is BC times the height to the base that is the radius of the green circle over 2. Okay? But what is AB? Actually, AB equals to A, that equals to 13 units. Okay? And what is AC? AC actually equals to C, that equals to 14 units. And BC equals to B, that equals to 15 units. So in total we got that 84 equals to this expression. Here we can take R over 2 as a common factor out of this expression. So we will get that 84 equals to the common factor that is R over 2 times, inside the brackets we will have here 13 plus 14 plus 15. So we got that 84 equals to R over 2 times 13 plus 14 plus 15. 13 plus 14 is 27, 27 plus 15 is 42, so I'll write it down. In total, we got that 84 equals to R over 2 times 42. Okay? We got that 84 equals to R over 2 times 42. 42 over 2 is 21, so I write it down. So in total we got that 84 equals to 21 times the radius of the green circle. Here we will divide this equality by 21 in order to get the radius of the green circle. We will get that 84 over 21 equals to the radius of the green circle. the radius of the green circle equals to 84 over 21, and 84 over 21 is 4, so I'll write it down. So we found out the radius of the green circle. Actually, the radius of the green circle equals to 4 units. The radius of the green circle equals to 4 units, and the area of any circle equals to pi times the radius of the circle squared. So the formula for the area of any circle is pi times r squared, and we have already found out that the radius of the green circle equals to 4 units, so we can substitute r by 4, and we'll get that the area of the green circle equals to pi times r is 4, r equals to 4, so it is pi times 4 squared. So the area of the green circle equals to 16 pi square units. Or in terms of numbers, the area of the green circle equals to 50.265 square units. I will repeat again, the area of the green circle equals to either 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, so in the next step, I will present to you a second method to find out the area of triangle ABC. Second method, to find the area of triangle ABC. Again, I will show you a second method to find out the area of triangle ABC. Actually, in this method, we will use the law of cosines in order to find the area of triangle ABC. So, what is the law of cosines? First of all, I want to emphasize that the law of cosines is valid in any triangle, so I write down that in any triangle, you can use it in any triangle. So actually, if you have triangle ABC, And we know that side AB of triangle ABC, this triangle, equals to A units, side BC of this triangle equals to B units, and side AC of this triangle equals to C units, and the angle between side AB and side BC is theta. Okay, so according to the law of cosines, C square equals to A square plus B square minus 2 times A times B times cosinus theta. Okay, and this equality is valid in any triangle. C square equals to A square plus B square minus 2 times AB times cosinus theta. So we actually can implement the law of cosines in our triangle ABC, because we know that in our triangle A equals to 13 units, B equals to 15 units, and C equals to 14 units, and the only missing variable here is cosinus theta. So we will put the data inside this equality and we find out the value of cosinus theta. Okay, we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. So C squared is actually C equals to 14, so C squared is 14 squared, and 14 squared is 196, equals to A squared. A equals to 13 units, so A squared is 13 squared. 13 squared is 169, plus B squared. We know that B equals to 15 units, so B squared is actually 15 squared, and 15 squared is 225, minus 2 times A times B is 2 times 13 times 15 is 390 cosinus theta. So in total we got this equality. Here 169 plus 225 equals to 394. So we got this equality. So here we will subtract 196. We will subtract 196 from this equality, and we will get that 0 equals to 198 minus 390 cosinus theta. Here we will add to this equality 390 cosinus theta, and we will get that 0 plus 390 cosinus theta equals to 300 cosinus theta. This equals to 198. Okay. So here we can divide this equality by 390 in order to get the value of cosinus theta. So cosinus theta equals to 198 over 390. 198 over 390 equals to 0.507962. So we got that cosinus theta equals to 0.507962. Okay, cosinus theta equals to 0.507962. Here, in order to find out the value of theta itself, we will operate the inverse function of cosinus on the outcome 0.547962 in order to find the value of theta. And the inverse function of cosinus is arc cosinus. So arc cosinus of 0.507962 equals to 59.49 degrees, or theta equals to 59.49 degrees. So we found out that theta equals to 59.49 degrees. So here we can write that actually we can draw the triangle ABC again. We will draw our triangle ABC again. We know that AB equals to A, that equals to 13 units, BC equals to B, that equals to 15 units, and AC equals to C, that equals to 14 units, and we have already found out that theta equals to 59.49 degrees. Okay, so this is our triangle ABC. So here we will draw a perpendicular to side BC of triangle ABC from point A. So this is a right angle. This is also a right angle. And we will name the point of contact between this perpendicular and side BC. We will name this point D. And we will define AD as edge because AD is the height of triangle ABC. So what is the value of sinus 59.49 degrees? Actually, the value of sinus 59.49 degrees equals to h over a. Okay, the value of sinus 59.49 degrees equals to h over a. But we know that a equals to 13 units, and sinus of 59.49 degrees equals to 0.8615, all equals to h over a is 13. So we will multiply this equality by 13 in order to get the value of h. So h equals to 13 times 0.8615, that is actually 11.2 units. Okay, so we found out the value of h. H equals to 11.2 units. So the area of any triangle equals to the base of the triangle times the height to the base over 2. That is the area of any triangle. And the area of triangle ABC, our triangle, will be equal to the base of the triangle, that is 15 units, times the height to the base. The height is h, that equals to 11.2 units because of the fact that the height creates 90 degrees with the base, so the height is indeed h. So it is h that equals to 11.2 over 2. So the area of triangle ABC equals to 15 times 11.2 over 2. 15 times 11.2 is 168 over 2 is 84. So the area of triangle ABC according to the second method equals to 84 square units. Okay. Again, we found out that the area of triangle ABC according to the second method equals to 84 square units. Okay. So in the next step I will present to you a third way to find out the area of triangle ABC, or a third method to find out the area of triangle ABC. Again, I will show you a third method to find out the area of triangle ABC. So actually, in this method, we will divide triangle ABC to two triangles, to two right triangles. The first triangle will be the following right triangle. So this is the first part of triangle ABC after we divided it to two parts, and this is actually a right triangle because it obeys to the Pythagorean theorem. The Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say 13 square equals to 12 square plus 5 square. So we will check if 13 square equals to 12 square plus 5 square, and if it is true, then this is a right triangle because the Pythagorean theorem is valid only on right triangles. So 13 square is 169 equals to 12 square is 144 plus 5 square is 25, and indeed 169 equals to 144 plus 25, and the second part of triangle ABC, after we divided it to two right triangles, is actually 12, 15, and 9. So this is the second part of triangle ABC after we divided it to two right triangles, and we will prove that this is a right triangle by proving that it obeys to the Pythagorean theorem that states that 15 square equals to 12 square plus 9 square. 15 square is 225 equals to 12 square is 144 plus 9 square is 81, and indeed 225 equals to 144 plus 81. Okay, so actually in this way we proved that if the base of the triangle of ABC equals to 14 units, then the height to this base will be equal to 12 units, and the area of any triangle equals to the base times the height over 2. So the base is 14 units times the height to the base is 12 over 2. So the area of triangle ABC equals to the base times the height over 2. Here 12 over 2 is 6, so the area of triangle ABC equals to 14 times 6, that is 84 square units. Okay, so we found out in the third way that the area of triangle ABC equals to 84 square units. Okay, so in the next step I will show you a second method to find the radius of the green circle. Okay, the second method, second way to find out the radius of the green circle. Okay, a second method to find out the radius of the green circle. Actually, we know that in any circle that it is inscribed inside a triangle, so in any circle that it is inscribed in a triangle, we can use the following formula that states that the radius of that circle that is inscribed in a triangle equals to delta over S. Okay, the radius of the circle that is inscribed inside the triangle equals to the delta, that is the area of the triangle that contains the circle, over the semi-perimeter. S is the semi-perimeter of the triangle that contains the circle. So we have already found out that delta, that is the area of triangle ABC, equals to 84 square units. And the semi-perimeter of our triangle ABC equals to 21 units. Okay, we know that the area of triangle ABC equals to 84 square units and the semi-perimeter of triangle ABC equals to 21 units. So the radius of the circle, the radius of the green circle, will be equal to delta over S, that is actually 84 over 21, it is 4 units. Okay, so the radius of the green circle equals to delta over S. Delta is the area of the triangle that is inscribed, that contains the circle, that is 84 square units, and the semi-perimeter of triangle ABC is 21 units. So the radius of the green circle equals to 4 units. And we know that the area of any circle equals to pi times the radius of the circle squared. The area of any circle equals to pi times the radius of the circle squared. And we have already found out that R equals to 4 units. So we can substitute R by 4 because R equals to 4. So the area of the green circle will be equal to pi times R squared, and R equals to 4, so it is pi times 4 squared. That is actually 16 pi square units, or in terms of numbers, the area of the green circle will be equal to 50.265 square units. Okay, so the area of the green circle equals to either 16 pi square units, or in terms of numbers it equals to 50.265 square units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the area of this green circle, and the green circle is inscribed in triangle ABC, and we know that AC equals to 14 units, AB equals to 13 units, and BC equals to 15 units. And we also know that side AC of triangle ABC is tangent to the circle at point E. Point E is the launch point between tangent AC and the green circle, and we also know that side AB of triangle ABC is tangent to the circle at point D. Point D is the launch point between tangent AB and the green circle, and we know that side BC of triangle ABC is tangent to the circle at point F. That is to say, point F is the launch point between tangent BC and the green circle. And we want to find out the area of the green circle. Actually, we defined AB as A, that is to say AB equals to A and A equals to 13 units. We defined AC as C, that is to say AC equals to C, that equals to 14 units, and we defined BC as B, that is to say BC equals to B, B equals to 15 units. And then I presented to you a new term that is actually the semi-perimeter of a triangle, and actually the semi-perimeter of any triangle equals to the perimeter of the triangle over 2. Okay, so then we found out the semi-perimeter of our triangle ABC, and the semi-perimeter of our triangle ABC equals to A plus B plus C over 2. So the semi-perimeter of our triangle equals to 21 units, and then we found the area of the triangle ABC according to a special formula that states that the area of any triangle equals to the root of this expression when S equals to the semi-perimeter of the triangle, and A, B, and C are the sizes of the sides of the triangle. We have all the data inside of triangle ABC. So we put the data inside this formula, and we found out that the area of our triangle ABC equals to 84 square units. And then we actually defined the center of the green circle as point O. We connected together points A and O by a straight line. We connected together points O and B by a straight line, and we connected together points O and C by a straight line. And then we will draw 3 radiuses of the green circle that starts from the center of the circle and ends at the launch points that are actually points D, E, and F. The launch point is the point of tangency between the tangents of the circle and the circle itself. And we actually have a rule, I call it rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to the launch point. So according to this rule, whenever you draw a radius that is drawn to the launch point, then that radius will be perpendicular to its tangent. So this radius is actually drawn to the launch point, that is point E. Therefore, this radius is perpendicular to its tangent AC, that is to say this is a right angle and this is a right angle. And also we have this radius that is drawn to the launch point, point D. Actually it touches the launch point, point D. Therefore, this radius is perpendicular to its tangent AB, that is to say this is a right angle and this is also a right angle. And the same thing is true about the third radius. This radius is drawn to the launch point, actually it touches the launch point, point F. Therefore, according to rule number 1, this radius is perpendicular to its tangent BC, that is to say this is a right angle and this is also a right angle. And then we created the equality that states that the area of the sum of the areas of the three small triangle AOB plus the area of triangle AOC plus the area of triangle BOC equals to the area of the big triangle, because of the fact that triangle ABC contains exactly those three small triangles. So the equality states that the area of triangle ABC, that equals to 84 units, equals to the sum of the areas of the three small triangles, triangle AOB, triangle AOC, and triangle BOC. And we know that the area of this small triangle equals to the base of the triangle times the height to the base over 2, that is actually AC times the radius over 2. In the same way we calculated the area of the other small two triangles. So the only missing variable that we have in this equality is the radius of the green circle, and we found out that the radius of the green circle equals to 4 units, and the area of any circle equals to pi times the radius of the circle squared. R equals to 4, so the area of the green circle equals to 16 pi square units. So in terms of numbers, the area of the green circle equals to 50.265 square units. Then I presented to you a second way to find out the area of triangle ABC. We actually used the law of cosines that is valid in any triangle. According to the law of cosines, C squared equals to A squared plus B squared minus 2 times AB times cosinus theta. We know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. And the only missing variable here is cosinus theta. So we put the data inside this equality, and we found out that theta equals to 59.49 degrees. Then I draw triangle ABC again. We know that theta equals to 59.49 degrees, and so actually sinus of 59.49 degrees equals to H over A. And we found from this simple equality that H equals to 11.2 units, and the area of any triangle equals to the base of the triangle times the height to the base over 2. So the base equals to 15 units, the height equals to 11.2 units. So the area of triangle ABC equals to the base that is 15 times the height to the base that is 11.2 over 2. So the area of triangle ABC, according to the second method, is 84 square units. Then I presented to you a third method to find out the area of triangle ABC. In this method, we actually divided triangle ABC to two right triangles. This is the first part of triangle ABC, and this is the second part of triangle ABC. And in this way, we proved that if the base of the triangle is 14 units, then the height to the base is 12 units. And we know that the area of any triangle equals to the base of the triangle times the height over 2. So the base is 14 units, the height is 12 units. So in total we found that the area of triangle ABC equals to 84 square units in the third way. And then I presented to you a second way to find out the radius of the green circle. Actually, in any circle that is inscribed inside a triangle, we can use the following formula that states that the radius of the circle that is inscribed inside the triangle equals to the area of the triangle that contains the circle over the semi-perimeter of the triangle. And we have already found out that the area of triangle ABC equals to 84 square units and the semi-perimeter of triangle ABC equals to 21 units. So the radius of the circle will be equal to the area of triangle ABC, that is 84 square units, over the semi-perimeter of triangle ABC, that is 21 units. So the area of triangle ABC equals to, so the radius of triangle, the radius of the green circle equals to 4 units, that is the area of triangle ABC over the semi-perimeter of triangle ABC, equals to the radius of the circle that is inscribed inside the triangle ABC, that is 4 units. So the radius of the green circle equals to 4 units. And after we know that the radius of the circle equals to 4 units, it is very easy to find out the area of the circle, because the area of any circle equals to pi times the radius of that circle squared. And we have already know that the radius of the green circle equals to 4 units, so the area of the circle will be equal to pi times the radius of the circle squared, and the radius equals to 4 units, so the area of the green circle will be equal to pi times 4 squared, that is 16 pi square units. So in terms of numbers, the area of the green circle equals to 50.265 square units. Again, the area of this green circle equals to either 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, thank you very much.